Hi, in this lesson we're multiplying binomials and factoring trinomials. Remember that multiplying is like area of a rectangle. For example, if I multiply a length of 3 by a length of 2, I end up with a rectangle whose area covers 6 squares. If I multiply a length of 2 by an unknown length, we can give it a letter. We can call it x. In this case, x is something between 6 and 7, but we don't know exactly how long it is. But I want 2 of those. I can write the area 2x. And then if I want to multiply 2 by x plus 3, an x length plus a length of 3, then it would be reasonable to separately multiply the x length by the 2 for an area of 2x, and also multiply the 3 by the 2 for an area of 6. So our overall area is 2x plus 6. Now you'll try to decide which identity goes with the diagram. We're going to multiply an x length plus 3 by the same unknown x length. The area would look like this. So which identity represents this diagram? That would be choice A. We multiplied the x by the x plus 3, and the result was an x squared and 3 x's. Here's the same idea, but it's a little more complicated because we're multiplying two binomials together, an unknown length plus 3 and an unknown length plus 4. We can think of this total area as consisting of 4 regions. The area of each region consists of multiplying one of the things from the first binomial by one of the things from the second binomial. So up here, when we multiply the x from the first one by the x from the second one, we end up with x squared. X times x is x squared. When we multiply the x from the first one by the 4 from the second one, we end up with an area of 4 x's. When we multiply the 3 from the first one by the x from the second one, we end up with an area of 3 x's. And then there's one final product we haven't found yet. What do you think will be the area of the final section? That will be 12, because what we have not multiplied together yet is the 3 from the first binomial by the 4 from the second binomial, and 3 times 4 is 12. So how would we write this product as a trinomial? What is that area in there altogether? We would write it x squared plus 7x plus 12. We can easily see where the x squared and the 12 come from. The 7x comes from combining together the 4x and the 3x. Altogether, there's 7 x's. Now I'd like you to multiply together x minus 2 and x minus 6. Feel free to use scratch paper and draw your own diagram if you like. You'll need to be careful here about multiplying negatives together. And when you're ready, choose the product. The product of these two binomials is x squared minus 8x plus 12. We multiply the x's together to get x squared. When we multiply the negative 2 from the first one and the x from the second one, we end up with negative 2x because we're multiplying a negative 2 by a positive x. Same thing when we multiply the x from the first one by the negative 6 from the second one. Positive times negative is negative. But then when we multiply the negative 2 by the negative 6, negative times negative makes a positive. So altogether, we have 8 negative x's and a positive 12. We can use our understanding of area to go the other way. Start with a trinomial, factor it out into two binomials that would multiply together to make it. So we would like to factor x squared plus 8x plus 15. From the work we've previously done, we can tell that this region of the area represents the x squared. This region of the area represents the 15. But we have to figure out the areas of these other two regions in order to factor this correctly. These two areas will have to consist of terms that add up to 8x. So we need to find two numbers that add up to 8. It could be 1 and 7, it could be 2 and 6, etc. Two numbers that add up to 8. But notice that these two numbers also will need to multiply to make a 15, because that 15 in the lower right corner is going to come from multiplying these two numbers together. So we need to find two numbers that sum to 8, they add up to 8, but also these two numbers have to multiply to make 15. When you think you've found them, make your choice. Three plus 5 is 8. Also, 3 times 5 is 15. So our missing area regions are going to be 3x and 5x. So what do you think the factors will be that we can multiply together to make x squared plus 8x plus 15? This question was a little bit mean. Choices A, B, and C are really all the same thing, because it doesn't matter what order you multiply things in. That's called the commutative property of multiplication. So choice A and choice B, those are really the same thing. It also doesn't matter what order you add things in. Addition is also commutative. So choice C is equivalent to A and B as well. The 3 came from the factors of the 3x and the 15. What can we factor out of both 3x and 15? Well, that's a 3. And the 5 came out of the factors of 5x and 15. What can we factor out of both the 5x and the 15? A 5. Please try to factor x squared minus 3x minus 10 on your own. Feel free to use scratch paper, draw a diagram. You'll need to think carefully about positive and negative integers. Remember that we're looking for two numbers that add up to negative 3, but also multiply to make negative 10. The correct factorization is choice C, because negative 5 and 2, those add to make a negative 3, and they also multiply to make negative 10. We've been multiplying binomials and factoring trinomials.